So, anyone know about the exact number of the height of this building? Maybe not. You just need to Google search first, right? So we think that like some measurement, like a kilometer or meter, they are accurate measurement, accurate, and then you can rule it by the accuracy. But actually, when you see this building, then you need to Google search for the accurate height. But when I ask you about how many floors in this building, then everyone can say that, oh, it's 81 floors, right? Because it's easy to remember, right? So I think that's the trap of accuracy, because productivity measured by the accurate measurement, but no one knows about what the accuracy of the productivity means. So that's why we just need to highlight the productivity by the capability. Oh, I'm a little nervous right now, so please understand. So, so capability is easier to understand. So when you say that like one solo developer in charge of the entire development, it's easy to understand. Or maybe LiveOps or DevOps starting to code with the AI, it's easy to understand. And then just QA change the QA process by the automation, and then the fully automated by the AI. It's easy to understand. That's the power of the capability to understand. So it means that like capability for the AI is that how people can do something with the AI by the AI. So you can build like a one-man team, or maybe a 10-man team is capable of 1,000-man team. So that's the moment that we just need to change the productivity to the capability. So there's also another report from the Google Dora that they just made another report named the ROI of the AI software development. So if you see this report, you can uh, you can feel more you can feel not nervous anymore, because we are not the only company suffering because of AI adoption. So
Ổn là sao này? Em biết file thì ổn.
you didn't Ruben, you didn't blah blah blah. So many things you just need to learn. So, because like AI doesn't work well by itself. So like those kind of things will be depths. So human needs to verify and to guide the AI to the right result. So this is the normal development graph. So like this blue line is the normal graph we can guess, and then as long as we develop, and then development value and quality is starting to getting low because development is being more complicated. And for the first depth is the technical depth. So when we adopt the AI at the first time, then the productivity is crazy. So like AI coding faster than human, and then everyone's starting to use the AI, and then they just make something. So at the first time, you can see the orange graph that you can see the pump up at the first stage to adopt the AI. But the problem is no one's starting to use it, and or maybe you are being suffering by the technical debt, and now the productivity getting lower than normal development. One of the biggest problem is that AI has the shallow window, just like stallion horse. So when we keep the AI for the focused goal, then it usually starting to solve the local maximum problem. So it just focus on like small focused goal to solve. But the problem is that it's easy to miss the global goal over the entire project. So we can say that like global minimum. So this is a common problem for the AI reasoning. But if you just learn about computer science, actually, it's always happening. In the opposite side, we can have the local minimum, but global maximum. So if you care about the entire project, then you cannot see the detail. So like it's always like a trade-off between we just need to see the entire forest, or maybe we just need to focus on the detail tree. But currently, AI has a small window to understand about like because of the token size. So that's a problem. And then every AI starting to develop something new by the shallow window and shallow point of view. Then when we just starting to integrate them all together, then we see the problem. And then those kind of things are being the technical depth. And second one is the cognitive depth. So it's just related to how the team understand about the whole picture of the development. So this is the most serious depth in the AI era. Because one of the problem is that LLM and agents are too productive. So when they just produce like new documents and then new results and then new code and anything, then at some moment the people just give up about understanding about the result, and then we just call it as a cognitive surrender. Because this kind of the cognitive surrender is not only happening by the human limitation of the time, but another problem is that it's happening because of the project, or maybe it's because of the business problem. So for example, we need to deploy the new feature tomorrow, and then you are starting to use the AI, then what will you do? If you have a just working prototype and working code by AI until tomorrow, then maybe you will ship it. You will deploy it tomorrow because it's working, and we don't understand what's happening inside, but it's still working, right? So this is one of the reasons that we just fall into the cognitive surrender. And then, for example, like our system is down today, and I have only limited time to recover it. And I have a lot of AI I can use, so I can solve the problem. Then it's also happening because of the emergency. And also, it's also happened by the when QA is delays to the review something. So now AI too productive for the new feature, or maybe they have fixes for the emergency case, and then a lot of things starting to being stacked in the QA process. So like QA, and then we cannot hire like 100, 200, or maybe 1,000 QAs to review everything. So like QA is starting to use the AI, and now they just say that, okay, it's good to go, it's working. And then everyone's saying that, okay, it's good to go. So later then, maybe tomorrow, then there are more features to review by the QA, then they cannot take a look at it. And third thing is the intent depth. So usually game designers always say that this is important, and then this is a true meaning of this game design or something. But when we have the working system, people don't want to know about why it works. So let's say that we just made a new feature by the AI, but we cannot understand about the working logic of the AI, and then it just shortens some calculation only by the strange long number, but still work. Then what will you do? Maybe you just use the code, and then it will pass the test, and then QA say it's okay, and then it start to work. So we just call it like working code, working feature. Then we just ship it. But no one wants to take a deep look at about why it works. And there's more problem about why it works. So for example, one of the developer left the company, and no one knows about the intent, and he didn't leave any design document. Then what's happening? We have the working prototype, but maybe I don't know why it works, or maybe he just didn't write the design document, but we just implement it by the conversation. Then maybe I just leave it somewhere for the meeting notes, but I cannot find. Then no one cares anymore. So that's why no one asks about the intent. So why this is happening? What's different from the before? So previously, people gathered together and discussed and agree and aligned about working together. So context and the intent remain with the meeting notes and the documents. But recently, something changed. People modify the documents with the AI, and then people implement it by the AI, and they just don't know about the true meaning. Then since we just working with the AI, then we just skip writing documents and skip writing estimation, skip writing the plans. So, and then sometimes prompt or maybe LLM has a shallow token window. So at some moment that is when we exceeded the token window size, then AI LLM say that, oh, compression step 1, compression step 2, compression step 3. It's trying to compress and then compaction for the LLM because it has a shallow memory. So those kind of things make it worse because at some point, like compress, like this is a losing behavior because we just compress it like 5 times or 6 times. Then at some point we will lose the original intent. So like everyone is suffering at this age, and every year I have an opportunity to share the technical and technical trend with the M7 companies. And this year I just visited Amazon and Microsoft. And we just dropped the topic about this AI problem and 3 depths. So this is one of the case we've been shared with the Microsoft, and then Microsoft shared their experience about adopting AI or the software development lifecycle. So this is the evolution of the software development recently. So people started to use the code completion before, and after that they just moved to the chat, and then they just started to ask, and then they just use the agent, and then now we are using the AI coding agent, and then we just say that implement this. And then we don't give them any detailed design document anymore. So this is a hierarchy the Microsoft measure about the AI adoption. So first stage, usage. People are starting to use the AI. And the next stage, people think about engagement. So how we use the AI, what kind of AI we use. They just started to discuss about this. And third stage, they are thinking about engineering and productivity. So how can we measure it? And then how can we know this productivity or capability for the third stage? And the fourth stage, they are starting to ask about AI adoption solved business problem and business logics. So that's the measurement of the Microsoft about AI adoption. So Microsoft make a decision to AI adoption to the Visual Code. So every developer use the Visual Code, like maybe 99% of 99 is too much. Maybe 90% of the game developers using the Visual Studio Code, and then if they can adopt the AI to the Visual Code, entire Microsoft products will use the Visual Code, and then entire world will use the Visual Code with the AI adoption. So that's their smart decision to adopt the AI adoption to the Visual Code. And then if you go to the GitHub and type you can see the repository of the Visual Code, and you can see the current result. So this is a GitHub page. You can just Google it, and then it's public, so you can see it. Then after I just need to tell you about the results first. So when they just adopt the AI to the Visual Studio Code, their stable release cycle shortened from the 1 month to the 1 week. And then pre-release validation for the release, the like a QA process. And then it's just shortened from the 1 week to the half a day. So this is the result of the Visual Studio Code recently. And you can see the top committer on the right side. See? The number one committer is the Copilot bot. And number 3 and number 4 also coding agent. So let's see how they adopt the AI to the Visual Studio Code. It starts from the agents MD, and also you can see the agents MD in the GitHub repository. So it's I just checked it yesterday. It's a 154 line right now. So you can see the initial instruction to explain about the project. So like it's like a Claude MD, but it's a more common for the every agent. So if every agent read the instruction, then they can understand about how to develop the Visual Studio Code with the AI and AI agents. So let me explain briefly. So they just explain about the instructions and then coding convention and then architecture and process and then tools and prompts and the skills. They just implement it in the agent system .md, and then they also put it in the repository for the instruction, and then more they have detailed instruction by the hierarchy and layer, and they also provide a common skill to develop the Visual Studio Code by the AI agent, and then they have also like common prompts you just need to use for the AI agent to develop the Visual Studio Code. So this single repository based context sharing is powerful to develop the Visual Studio Code with your AI agent. And then after they build the AI adoption to the Visual Studio Code, now they suffering for the same problem, because AI write more code and then it's more productive. But teams they are suffering for the same problem, and they just experienced it for the separate AI system to review the code produced by the coding agent. And then also the AI generated input is contaminated. Then errors can propagate, and we just call it like AI pollution. So AI pollution and contamination is happen, and then they just roll back and then or maybe just review from the moment and then validate it by human judgment. And this is the case study from the Amazon. Actually, just Microsoft made a smart decision to adopt the AI to the Visual Studio Code, but Amazon at the first stage and early stage, they've been suffering for the failed attempts. So they just trying to introduce the AI to the entire company. But senior developers say that, AI coding is dumb, and then they are not smart. So I will code by my hands. And so senior refused to adopt the AI at the first stage. So they just want to improve the productivity. So they just brought it to the experiment project or side project. Or maybe they just brought the AI adoption to the junior engineer. And those kind of projects all failed. So after they have a series of the failed attempt, and then they just starting to review about the cases, and then they found this problem inside. So AI works well for the coding, but why their failure? Because writing code faster, but it's not good to judge the product. So like they just want to say that helping people to make a better decision. And so when they see the problem that AI can define the problem and they can define the goal, maybe not, because we just mentioned about the local maximum and global minimum problem. And then second one is that the requirement. Usually those kind of the requirement is written by the designer or maybe architecture, but AI it is not easy to understand about the product from the ground. So those kind of requirement is the AI cannot measure this requirement is right or wrong, and then design coherent. So it just inherited or bring the coherency from the design from the another product, or maybe inherited from the previous product. Then they also starting to be confused. This kind of like a new improvement is right or wrong or proper, and team working in the team working in the same context. That's another problem. So for example, like there is a team A and team B, and team A is focusing on the optimization, and then team B is focusing on the new feature. Then they have a different type of the context. And then also when they just using the AI, but still different type of local maximum but global minimum problem is happening between these two teams. And then also AI has a tendency to bring the users goal, and like team A's agent is willing to optimize everything, and team B's AI agent is trying to build something new all the time. So they are starting to fight each other, and like person can catch the LLM misunderstanding. So even though AI team A think that they are focused on optimization, that they are saying that we are doing the right thing, and then team B is implementing a new feature. It's not only by the AI, but it's also happening in the human being. So like team A and team B always struggling each other, and then they just go to their boss and then they say, oh, we just need to ship it today. And team B say, no. Optimization is not needed right now, and we just need to ship the new feature first for the value of the product. So it's not easy for the human being. So this kind of problem is happening, and finally they make a decision to bring all the senior engineers together. So Amazon have a engineering hierarchy named SDE is the stand for the software development engineer. So they have a grade like SD0, SD1, 2, 3, and above the SCT3, they have SSDE. SSDE is a senior software development engineer. So they just brought 8 SSDE together and give them the goal to solve the major problem of the Amazon solution. So that's the name of the team, is the Amazon Mental Team. And then they took the ownership of the critical major challenge to improve the AWS Bedrock. And then operating principle for the Amazon principal engineers, like experienced engineers, they have a initial goal for the experimental practitioner. So they are willing to adopt the AI. And then when they learn something, and then they just educate it and then advocate it to the entire company. That's that's their goal and culture. So the eight senior engineers, gathered together, and they just starting to redesigning the core process. So they just think that like coding is not a bottleneck, but judgment and then decision making is the problem. So they just want to fix it. So they just drop the Scrum and 2 weeks sprints, because nowadays the AI can code within 1 day. So 2 weeks decision is too lazy and too long. So they just shifted to the daily stand up, and then daily decision making. And then one more thing is that when they make a decision together, then they always do the co-location. So if possible, then they gather together within like one location. But if they cannot, at least they just use the Zoom meeting or Teams meeting to make a decision together. And then funny thing is that when they starting to argue, or when they have some conflict during the conversation, then they are starting to doing this, talk about some issue or topic, and then okay, let's see who's right, and let the AI code it first, and then they keep debating each other. But when during the debating or conversation, they already have the result, so they can see the proven prototype by the AI, like within 10 minutes. And maybe I'm wrong, and then maybe you're right, and then they can make a decision, and then they can code again. So it's happening within the team for the daily stand-up. So they just shifted from the productivity to the capability. So they define the business goal written on the post-it, and they just post it. They just write every business goal on the post-it, and then they just put it on the wall, and they're starting to erase it one by one when they solve it. So like these are the goals they just mentioned about like post-it, like they just want to reduce the on-call response time, or maybe onboarding new teammates, or align product, or maybe navigate the complex product knowledge, or automate the recurring operation, or generate release, or maybe QA and reports. So they just shift to the context-centric organization. So before usually engineers is being focused on the accuracy. So about, for example, like a syntax. So they just mentioned about the coding convention, and then they just mentioned about like a code readability, and then they just mentioned about like this pattern is right or wrong, or they just mention about like this is the right code, this is the wrong code, something like that. But they just shifted to the semantic layer organization. So like meaning and context is more important. They are more important than the syntax. So they established the core principle. So just like the Visual Studio Code, they just put it everything within the single repository. So they can have the shared context from one single repository. So not only for the code, but they just put the documents, and then specification and plans and matrices. So they just put everything in there. So, and then they always say that LLM doesn't know about something, then is out of the context. And when they starting to let the AI code something, then it can miss a single, maybe some context out of the repository. And they have another principle that LLM first interaction. So from this moment, no one can code by hands. No one can write the document by hands. They just let the LLM write the documents and codes. So they just share the prompts, and then they just share the skills. And then after that, any kind of LLM can make the result. So their ideal state definition of the ideal state is a little hilarious, but even if we design, even if we have code, so like even they just discard every code at every result. If they have a initial specification and initial design document, they can rebuild it with any different language, any different platform. That's their definition of the ideal state. And one more thing is that the managing the context window. So I just mentioned about losing context when the LLM is doing the compression and compaction. Then they just want to preserve the context accuracy, also named the original intent. So when, because like modern LLM still has a bigger window, token window, but still it has a limitation. So like if the token window is exceeded, then the compression and compaction is happening, and then they're starting to lose the intent between compression and compaction. So they have a recommended workflow. At the first time, they just at the first time when the LLM starts to start a project or feature, and let the LLM write the initial document and plan and goal for the feature. Then LLM writes it in as a document and then store it as a MD file, something like a plan.md or goal.md, and maybe run packet by MD, and then they just process that MD. They just write these kind of files and starting to implement with the LLM, and then they have some kind of checkpoint. So when the LLM exceeded the token window, then they just drop the code, drop the result, and go back to the checkpoint and read the entire document again, and starting to implement it again. But still, token window compression is happening. Then they go back to the planning and then make the plan as small as possible to understand by the still fit to the token window. So they make a smaller plan to execute. And then if they pass, then they just merge the feature to the main branch. So each step also has the estimation about the token window, and then also they have review steps for the generating code, and then in the later stage they just generate the original code and then merge them to the main repository branch. Also, they have steering ops and then LLM ops. So their major major coding agent was the Claude Code. So when the Claude MD or Steering MD, they just commit both of them to the Apple repository. So initially, Claude Code will read the Claude.md, but also other AI agent can read the steering.md. It's a more common form for the AI agent. So document and team agreed best practices and then instruction and like when you read about the agents MD from the Visual Studio Code, they just write everything in there. And then also they have a hierarchy and layer. So when they have a more detailed feature, then they just write another detailed steering MD or its protected features. So they just keep the steering up to date. And then also share team skills and MCP, just like Visual Studio